Hi, Dr. Mark here. Today we're going to look at another programming contest problem from Caddis, namely Haiku. Haiku are so hard. I am not good at them yet, but why should you care? Let's take a look at the problem. All right, when you go look up the Haiku problem on Caddis, basically it introduces you to what a haiku is, says that there is a haiku contest where everyone has to submit a poem, and they're judged on creativity, simplicity, beauty, and whether the poem is actually a haiku or not. And that's the part that our program is going to work with. So what we get as input is a number, which represents a number of syllables that are provided for us, and then that many syllables, right? And so these are the only syllables that are allowed to be in the poem at all. And then you get the haiku itself, which is 3 lines. And so what you're supposed to do is, given the syllables that were presented above, is this first line 5 syllables, second line 7, third line 5 syllables. If it is, then you output haiku. If there's no way to make it into a haiku given the list of syllables that you were provided with, then you put come back next year as your output. All right, so this one is a problem that we can tackle with a depth-first search procedure. And so let's take a look at that, and we'll look at a couple different inputs and trace it through a depth-first search just so you can see how this thing will work. So we'll look at the first line of sample input 2, shall I compare thee, and the last line of sample input 3 from Romeo and Juliet, the east and Juliet is the sun. So let's take a look at shall I compare thee, and we'll sort of draw it out and see how that works. All right, so here we are on our little whiteboard, and we have, again, my input that I'm looking at is, shall I compare thee? And I'm just going to assume that I'm storing my syllables in the order that they're presented in the input. And it turns out that if I start to try to match those syllables with the first part of my word, or first part of my line, rather, I'll find out that there is a syllable listed, shall. And so if I remove that syllable from the sentence and strip off the leading space there, then I've got shall I compare thee, or I compare thee, left, because I've already removed the shall. Likewise, there's also an I listed as the syllable in that list, and it's the first one I come to. So if I remove that, then I get down to compare thee. And now we get to sort of this depth-first search piece, because the first syllable that's listed in the list is actually a C. This is the first one that matches the beginning of the line. And so if I remove that, then I've got umpare thee. And then I would go through all of the syllables, trying to match them to the beginning of the line, and find that none of them work. And so I would stop there, and I would go back and try to find the next syllable on compare thee that matches. And it turns out that COM is one. And so then I'm left with pair thee. Suppose you're a potato, I'm going to pair thee. And then pair is a syllable that's listed next. And so I would just have thee left after removing the pair. And likewise, thee is listed as a syllable. So I'll remove that, and I'm left with nothing, an empty string, and 0 syllables left, right? And so if I start up at the top and say, I've got to try to find 5 syllables there, then my next level I'm looking to find 4, then 3, this would be 2, this would be 2, 1, and 0, and that's a successful find. And I won't try to go through and find any other matches, right? Because I just care if there's 1. Now, what about one that doesn't work at all? Let's take a look at that. So I'm going to make a new board here. And we're going to go, the east and Juliet is the sun, is my top level. I'm trying to find 5 syllables there. The The is one of the syllables listed, the first one we'd come to. So now I'm left with East, and Juliet is the sun. And obviously this one's not going to work. You can tell there's too many syllables, but we'll see how it would play out. East is also listed as one of the syllables, so I would remove that. And, not ant, and Juliet is the sun. That's at level 3 that I'm trying to find. And is a syllable that's listed, so I'll remove that. Juliet is the sun. That's at level 2. Now, Ju is listed as a syllable, so I've got Liet is the sun at level 1. Li is a syllable, so now I've got, after removing Li, I've got Et is the sun at level 0, and one more because Et is listed as a syllable, so remove the Et, and I've got is the sun and -1 if I've been subtracting from my syllable count as we go along, and that would be another fail, right? A return false type of a situation. So that sort of shows you how we're doing this depth first search, going down, trying all the possibilities that work until we either find one that does work or until we run out of syllables to try, in which case I would return false, or I get down to the point where I've used my number of syllables and I still have sentence left. All right, so let's go ahead and see how we would code that up. Okay, so let's do a Python program to make this work. The first thing we're going to do is read our input number, which is the number of syllables that we have. And then I will use list comprehension to build a list of those syllables. So this will just be what I read from the input repeated S times. And then I can get my 3 lines or stanzas of the poem. So S1 is equal to input, and then we'll do the same for 2 and 3. And at that point, I've got all of my input. So now what I need to do is write my recursive function that's going to do the actual depth first depth first search of this. So I'll just call it HKU for Haiku, and I'm going to pass in n, which is the number of syllables that I'm trying to match, and ln, which is the line that I'm trying to match that with. So we saw in our example on the whiteboard that if n is less than 0, then I've gone too far, used too many syllables, and there's still line left, and so I'll return false in that situation, which means I did not find a haiku. Okay? On the other hand, if n is exactly 0 and the length of my line is also 0, that's the good case where I used all of the syllables, the correct amount, and completely exhausted the line. So that would be a true situation. Now, then we have our recursion, our general case. And the general case will basically be to look through all of the syllables that I created before. And if the line that I passed into the function at this level starts with that syllable, then I'm going to recurse. And so I want to do a recursion, a recursive call, onto my haiku function with n-1 syllables, because I've just used one. And then I'm going to use array slicing in Python to strip off that first syllable and get rid of any leading spaces. So my line, I'm going to start slicing at the location of the length of the syllable and go all the way to the end. And then I'm going to do a strip on that so that that leading space gets taken off so that, because none of my syllables are going to begin with a leading space, right? All right. And so if that returns true, that function call returns true. Let me count my things here and make sure that I've got enough properly bracketed pieces. Okay. If that's true, then I did find a haiku, so I'll return true, right, at that point without going any deeper. There's no point on going any further. If I get all the way to the end of the for statement and never return true, I didn't find one of my haikus, and so I'll return false. I've got something that is not correctly, balanced. There we go. All right, so that's my function. Then my main program, if you will, to actually run this is just to check to see if my haiku function, HKU 5 stanza 1, is true, and HKU with 7 and stanza 2 is true, and HKU 5 syllables stanza 3. If those are all true, then that was a haiku, so that's what I'll print. Oops. And then, if it's not, then I'll print my better luck next time, come back next year. Okay, so there's my program. Let's test it on the sample input right quick before we submit. So I'll pop open a terminal. All right, so I have the inputs for input 1, 2, and 3. So if I cat those, 1.in, pipe it into Python, haiku.py. It says it's a haiku. If I do the same thing with sample input 2, it's a haiku. And lastly, for number 3, if I run that, come back next year. So looks like it works. Now we'll go ahead and give it a shot on the submission. And there we go, 0.08 seconds. All the inputs are correctly adjudicated, and we win, right? We got that one right. If we look at the stats, we'll see that we're just out of the top 10, I think, in terms of time taken. Some people are really good at optimizing their Python and making it run in like no time at all. So we're not too far from the top 10. Still, pretty darn good. All right, that's the solution to the haiku problem. Thanks for checking in. We'll catch you next time.